Good afternoon, everyone. My name is Laura Moreno Corrales. I am going to talk about the work carried out during my stay in the Cours National Superior d'Arts et Métiers in Paris. This stay is part of the doctoral and research training within the European project CoMetaS. It is aimed at establishing an interdisciplinary exchange network between European research groups with the objective of solving a new scientific and technology challenge with a high practical interest for the industry. My stay began on June 10, 2024 and finished on July 31st, 2024. My stay was supervised by my thesis director Francisco Montans and by Francisco Sinesa, who was responsible for my stay in Paris. This stay is part of Work Package 4. The purpose of this work package is to develop components made of ultimate functionality grade metamaterial using double-scale inverse analysis through surrogate modeling. So for this aim, first optimization of material cell families and later development of ultimate functionally grade metamaterial for component mechanical objective. The character of the work package is to use computational mechanics together with machine learning technique, as well as a good prototype design. Talking about my background in education, 29 Industrial Engineer, University of Seville, Spain, and 2020 Master in Technology Education, International University of The Rioja in Spain, 2024 PhD in Aerospace Engineering, Universidad Politécnica de Madrid in Spain. Regarding my pre-PhD from 26 to 28, teaching assistant professor in the engineering technology field in its different specialties, civil, aerospace, and industrial in Seville. From 28 to 2020, teaching assistant professor in the engineering technology field in Cádiz. So, research collaboration with the University of Seville. Currently, I am teaching assistant ayudante in the Universidad Politécnica de Madrid, Spain. The order in which I will present the tasks performed will be: firstly, a brief introduction to mechanical metamaterials as well as to the defects that appear when using additive manufacturing technique. Secondly, I will discuss the objective of this secondment. Thirdly, I will show the result of time, and finally, I will present the conclusion. Mechanical metamaterials are materials designed from the geometric repetition of a unit cell that is a defined pattern. These materials are considered architecture or artificial material because they are designed with configurable properties at libitum. So, metamaterial present property to highlight from the mechanical point of view both at microscopic and mesoscopic scale. Being in tool considered as a continuum scale material. However, for its construction, it is necessary to use additive manufacturing technique, such as 3D printing techniques, which are associated with a series of defect and statistical variations that modify the final mechanical property of the printing material with respect to the initial property design in the CAD models. This slide shows a model built using 3D printing techniques and a photograph of a tested model with a series of defects observed. Among the most common defects associated with 3D printing technique, the following can be highlighted. For example, ondulation. This defect is due to inaccuracies between the model design in CAD and the printed model due to shrinkage and deformation that appears both in the base plane of printing and the direction of construction of the material. Other defect is, for example, conicity in the edges of the lattice. This defect is due to the non-homogeneous deposition of the material. Finally, porosity gradient. This defect is due to the appearance of voids in some areas of the melt material. The objectives of this secondment are first to design a metamaterial structure in MATLAB without damage. Second, generate a data set by randomly modifying both the position of the damaged bar in the structure using variation of stiffness and the position of the vertical force. Finally, machine learning techniques will be used to predict the structural collapse of the metamaterial structure. For each case, the program design in MATLAB provides the bars subject to axial tensile and compressive forces, the bars that are buckling, the displacement field, the vibration models, as well as their eigenvalues too. This slide shows the case of damaged bar 1 and the force applied at node 12. In this case, the behavior of the neural network built by 3 hidden layers is being shown without considering the input and output layers. Each hidden layer is made up of 150 neurons, and for the case study, it provides us with an error of around 3%. The conclusion from this workshop that 3D printing introduces relevant defects of a statistical nature. So, this defect have a major impact on the mechanical properties of the printing material. Therefore, it is necessary to take into account the different types of defects and their statistical distribution to model the real behavior of the material. Finally, in a structure, the cellular architecture of the metamaterial has an important impact on the susceptibility of the structure to the defects associated with the cell. Thank you very much for your attention.